Génial. So hi everyone, I'm Justine. I'm with Modern, which is the company that started OpenRewrite, basically. So OpenRewrite is our love child, our open source project that anyone can go and use. Obviously, Modern has to, in some way, sell this to someone. So the way that we differentiate Modern from OpenRewrite is Modern is where you'll take this OpenRewrite framework and be able to use it at scale. So if you're a team that has more than 10 repos, then it's already really worth it to switch to Modern. So if you're interested in, incorporating this in any way in your workflow, whether it's the open source or more with Modern, we can definitely talk about this after. I'm on the research and development team more. I'm the only AI person there. I had an intern from Mila for a while. That was fun, and he's coming back in a month or so. So this is, going to focus a little bit more on the work that I've done. I can't, just start off with only my work. I need to kind of show what is OpenRewrite, what's the technology behind it. It can be a lot to digest at first, so feel free to stop me at any time. If you want me also to explain it in French, a sentence that maybe you're not sure you understood, the little nuances in English, please let me know. I'll be happy to. All right, so this is the Halloween themed, where we are now, resurrecting legacy code. It's truly our bread and butter, right? If we see a company that comes to us and they say, hey, we're 100 developers or more, we code in Java and our code is old, we're like, love it, come to us, we'll talk to you. So I felt like this was a nice way to incorporate it. All right, so what is OpenRewrite, the actual framework in itself? So the technology starts with the lossless semantic trees, and I actually think it's an interesting story from where OpenRewrite was born at first. So we have our co-founder, Jonathan, who was working at Netflix. OpenRewrite was developed when he was working there, although it wasn't called OpenRewrite at that point. So he was in charge of basically making sure that projects could be integrated together, because Netflix has a very culture where everyone can use whatever library package they want. They just want the job to get done fast, and then we'll manage to Frankenstein it together kind of thing. That's their culture. That's one way to code. So Jonathan was kind of, trying to fix some of that. I don't want to call it mess, because I don't think it's mess necessarily, but to make it all work together, basically, and make it one fluid project. So he would sometimes go see some teams and would say, hey, would you mind migrating to this version? Or would you mind using this library or this package instead of this one to do this functionality or whatsoever? And then they would say, look, I'm busy, I'm working on this new feature. Sometimes I'm sure they were blunt and were like, I don't feel like it and I don't have to. So they would say, though, but if you, show me the pull request, I'll accept it. So, okay, he got told that a couple of times, and as you can imagine, it can get a little frustrating. So he decided, all right, well, I'm not going to start, myself coding this for, dozens of teams. Why don't I write a framework? And he had this idea of using basically the structure of the code to be manipulated, right? And so the idea was born from that. So who here is familiar with abstract syntax trees, ASTs? Okay, so if you take your code and you parse it, will be left with a tree where, say we were to take a little, just a method, and so we're taking the bottom part of a tree, just a method definition. You would have, some information about what the signature is, but say we get actually inside what the code is doing inside the actual body. What if there was an if? Well, you can have that if, basically, that's a node that contains that information. So as you're running through this code, you basically can go through it, and then you might have, this is a method invocation that does this and calls this argument, and you basically have this syntax tree. So by parsing the code, you're left with a structure that contains the information that you need, that is relevant for when it's time to actually run the code. So the idea is we have this abstract syntax tree, and then Jonathan, and I believe at that point he was working with others, they kind of super it, they Frankenstein it. Here you go, I'm making it Halloween again. They really make it super powered by adding basically, first of all, white space, because if you're going to make change to a code, you want to make sure you keep the indentation the same, the comments the same, that kind of the things that are outside of just the syntax are important to developers, so you can't remove that. But they also add type attribution, which seems like a simple thing at first, but it's actually a pretty difficult thing to make sure that your code has in the tree. Yeah, so type attribution will be basically, you'll be able to go get the type of an object or a class, even though it's not from the same project. So it's more than just, oh, okay, this is an object. You have more basically for the type. So that's basically the gist. So this is why it's a lossless semantic tree. So you might recognize, like, we kind of went from abstract syntax tree to lossless semantic tree. The reason for that is once Jonathan was presenting to some group, and someone kind of was like saying, oh, well, that's not an abstract syntax tree, because you actually are keeping the white space and you're keeping the type. And so he was like, that's more like lossless in some way. And Jonathan was like, yeah, I like that name. That actually fits really well. So from there, he ended up calling it Lossless Semantic Tree. And I'm sure today our marketing department is very happy with that, because I find it's got a nice ring to it. All right, so how do we actually make change to code? So we were talking about this legacy code that needs to be updated in some way. So we have what we call recipes. And so these recipes will take as input this abstract syntax tree. I will now refer to them only as lossless semantic trees, or LSTs. So the recipe will take the LST, and we'll need to basically find a way to navigate, to walk through down the tree and make changes as needed. So say we wanted to change, all methods that were called foo to bar, all method invocations. What you would want to do is basically start from the top of your repo or the tree and walk down until you find a method invocation. So you could do that. Okay, I'm at a method. Once I'm at a method invocation, I can check, well, what's the name of the method? Is it foo? If it's not, continue searching. And you kind of walk through. And then you can find another method invocation. You say, is that foo? Yes, it is. All right. Then I know to now change the value inside that node here to bar, such that when it's time to print from that AST or unparse, then that change will actually be integrated. So what's great, it's better than just regex, right? Because if you had, a comment in there, and for anyone that's worked with regex will know how many edge cases there can be. Here you're actually certain that the change was only made if it was truly a method invocation that was called foo that gets changed to bar. You can also add rules to be like, only in files of this name, then the sky's the limit, right? It's really just, the idea is to have a framework that basically permits you to walk through your code and do changes as needed in the right spot. And then you can add logic to it, right? So how does this help with Spring Boot? Anyone here code with Spring Boot in Java? Okay. Well, use it, yeah. All right, perfect. So let me show you how it looks in here. So what we have here is actually what we call recipe. So I know it looks like a tree, and I often hesitate if I should put those two slides so next to each other. But it's a similar thing here where you basically have this recipe is code that basically does the logic that I just described, this thing about how do I walk through the tree. So what I described, this idea of like you're walking down the tree, you look at where you are in the tree, and based on that, you do an action or you keep searching. That's called, it's based on the visitor design pattern. So this idea is that as you're walking down the tree, you really check your environment before knowing if you do something. And it can be quite powerful because you have this logic that can be written so easily now thanks to that. So if we go see what actually this looks like in real life. So let's go here. Let's go see the builder. It's still showing perfect. So this is the same migration. This is the migrate to Spring Boot 3.2. I believe I might have added 1 or 2 recipes in there because I was testing something earlier. But basically what we have here is a bunch of actions that are defined by these recipes. So one key thing to understand is that a recipe in itself can be just, a set of rules when you see this, do that, or a recipe can be composed of other recipes. And that's when you actually get a whole migration and not just change foo to bar. So the idea here, is there one that's calling anyone? How about this one, the micrometer? All right, well, here's some easier ones, which is, just upgrade the version, rename the package name. This is what it goes to now. Or you can have change type here, which is going to be actually make a lot of changes, most probably. Yeah.
Can you talk a little bit about how like a rule or an instruction corresponds to this visualization on the left?
Yeah.
Like I can see that being kind of like a tree of code, but I don't understand how that's like a
it's a, don't see it as a tree of code, but more a tree of set transformations. So if I know that every node here, I'm going to take one randomly. So here we have, don't get nauseous. Sorry, I'm still learning how to navigate this thing. All right, we got a good angle. So we have this, this kind of like parent node of a recipe. So this is more like, this is just a defined transformation from A to B, from where your code goes from state A to state B. The idea here is that every single thing inside of it is going to be also here a recipe in itself.
So recipes are hierarchical, and so is the model of the code.
Exactly. Yeah, exactly. They're just composed of different things, which is why I said I hesitate to put those two slides so close to each other, because I think I jumped from one tree to another tree. But it's exactly, I think you get it now. So it's really the transformations are hierarchical. Like you said, I actually like using that term a lot to describe this. It's a series of steps you need to do. And the idea is that each step might be composed of more steps. So if we go back to the bigger picture here, you can see that we have a lot that needs to be done. But there can be some simpler ones here. If we go to change method name, I don't want it in camel. There we go, let's go in Java. So here, you can take a method pattern and then change it to whatever you want, and you have some options here. So these recipes kind of become these building blocks of transformations, and that's why they become useful to compose into bigger migration strategies or transformations, rather. From there, we have this little silly examples from foo to bar, but you could have something that is actually more useful, like changing from Prometheus to Prometheus metrics that we saw earlier, or maybe it was registry, I forgot. So that's basically the idea of recipes. Yeah.
What is your migration from Spring Boot 3.1 to, I suppose you're working on 3.4 right now? What does that look like?
Yeah, sure, we can go see it.
Is that a fairly structured hierarchy, or is it more?
No, it's going to look like this. And then, so that's kind of what's interesting here. Do you notice how here in Migrate Spring Boot to 3.3, we have Spring Boot 3.2, and then we have 3.1, 3.0, 2.7. So there's always going to be, first, we want to pick up the code wherever it's at. So if your code is at 2.6, we want to make sure we're able to pick it up. But if it's already at 3.2, we can also just pick it up from there. So the transformations are built such in a way, and they're tested such in a way that they'll never do a transformation when not needed. So if all your foo's already bars, it's not going to go ahead and add more bars than it's necessary. So that's why we're able to kind of keep growing all the transformations and have these more steps. Regarding Spring Boot 3.4, let's see if we have it.
You're working on it right now, I imagine.
Not my department.
I see.
But seems like it's still 3.3. Depending on what are the changes, it's actually something that's interesting. We're trying to see, whose responsibility is it to write recipes. Obviously, we write a lot of them. Our clients write some. We also want libraries provider to write some, and some do. There's when they make a breaking change, they just have a JSON or something. I forget exactly how they have it, but in a way that's easy for us to parse and be like, all right, this method is now called this method, or they've moved this package to this one, that kind of stuff. Yeah.
So like, how much effort is it to create a recipe? Like, if is it the value return? Is it really just for when you have multiple legacy projects, or like would you still see a value return on a single project?
It depends. I think it's a really good question to answer your first one about how long does it take to write a recipe. If your changes are kind of more migration based and they're a little bit more on change this package to this package, change this import to this import, those are fairly easy to write because, as you saw in the change method names, we have them ready to go and you can just customize them to whatever you need. When it gets a little bit more difficult to write a recipe is when you actually have to write the first block, and we can go see the find method names actual code.
You need to like write
the visitor design pattern actual part.
I guess like a step. I saw you talking about the form, but I guess what you're saying is like this. One of these forms is like a migration, has some source code that has to be written.
Exactly. Yeah. So this is what we like, the building block itself, the recipe. So let me make it a bit bigger. So okay, pretty simple, right? It has a name, or rather, this is the name here. This is the description. There's really nothing more to say, right, about it. But this is where it gets interesting, is that visitor. So remember how I was telling you about the visitor design pattern? As you're walking down the tree, you want to decide what to do based on where you are. So we have here this tree visitor that just goes and visits every tree. So here, we're able to override this visitor to say, okay, I want this now to be your new thing that you'll do. So let's see here. I'm just going to go down because it's there's like preconditions to make it faster, but it's not outside the scope of today. But here, if we go see this method declaration, so we're overriding, or sorry, I should have highlighted this one. What we're overriding here is what to do when you see a visitor, when you see a method declaration here, or invocation, if we want to see the other one. So maybe we'll do invocation just to stay on what I was talking about. So the idea here is that you take the method in and you take the context. So the context will have kind of like the cursor, which file you're in, that kind of information. And the method is actually the method invocation, just that. From there, you're able to go see, okay, well, does it match the thing that I was trying to change? And if it does, then I'd like to change it to the new things. This is changing it to the new one, basically. And then I can return this method invocation. If we were to rewrite the same thing, and for some reason we wanted to just visit the same method and do nothing, but for some reason we wanted to override it, what we could do is just return this method, right? Or really, you want to keep visiting in case it's a chained call. But this is the idea, basically. As you're inside a part of the code, you want to kind of decide what to do based on it. Any questions about this code here? I think if you're able to understand this, then you're very ahead in understanding how to write a recipe. So if it's something you guys are interested in, I'm happy to spend another minute or two.
I'm a little bit intrigued by this notion of visiting every branch of the tree. That sounds very computationally exhaustive.
Mm-hmm.
What mechanisms do you have to optimize, or how do you say improve the computational efficiency?
Yeah, of course. I say we visit every node, we don't, right? There's a way to have this information kind of pre-computed. So we have the preconditions. I'm not exactly sure what it is, but I can guess it's going to be check if it actually uses this method in it, so that you don't have to walk down every single one of those nodes further down in the tree, basically. So that's one of the things from there. And then if you write the recipe, you say only check overridden or don't check those that are overridden. So if you see something is overridden, you can kind of continue through. You don't need to check everything. So in the background, we're not actually checking every node, but for simplicity of explaining, that's what I say.
I'm thinking maybe in terms of parallelization, you can run the, how do you say, to run the part of the code that verifies every single node, and in parallel send verification paths in particular directions in order to achieve the code completion. And when a certain criteria is filled, then you just terminate the parallel process. Have you looked into doing that?
I'm pretty sure they do. But again, I'm more on the AI side. But yes, this.
You're running this on more than one GPU. You mentioned that your master's station running.
Yeah, that's my master's.
Yes.
This is my work at Modern, basically. There's no GPUs. It's only CPU.
Okay.
Yeah.
Understood.
Yeah. But so if you're interested into it, you can go look at scanning recipes. I think that would be a nice, also interesting. It might answer some of your questions. It's one way to basically just do this pre-check that you're talking about. But in general, yes, it's not just like one worker. There's going to be more things run at the same time on this. Yeah. That's a good question too. No, not anymore. Whew, we are out of the Java only slump. So we have support. We did COBOL like a year or two ago. That was an interesting one to work on. C# now and Python. I would say those four are the most constructed one. Python and C# are still kind of newish, but they're usable. So that's really great. And then TypeScript is coming soon, and JavaScript.
Why COBOL?
Because a lot of old code from banks. Yeah, COBOL runs our banks. Yeah, no, of course. No. Yeah, right, we should. Yes.
So I know there's Modern, the commercial entity, and OpenRewrite, open source entity, and different people write the different recipes. Like at Modern, are they like, what's the recipe that has the most need in the market and we can sell more? Like, is that kind of where they decide which recipes to write? And also, is there a different decision-making process in the open source community, or is it?
Yeah, definitely, like, upgrading Java version, that's a big one. That's something that a lot of people want. They are kind of stopped in growing and using some packages because they're left behind in like Java, 7. So Java is definitely a really powerful recipe that I don't think ever a customer came to see us and said, we wanted this, we just wrote it. Spring Boot is also used a lot. So yeah, definitely we'll kind of like pre-write recipes for migrations that we see are really useful. I think we're moving past that a little bit now, where we're more writing recipes that can be used for someone else to write recipes, right? Because we were talking about having these building blocks. And to have it be either automated, by, having that provider, when they write a library, they have a way they could actually run a recipe to find out what breaking changes are there and generate the recipe automatically from that. So we want, to kind of move past that. Obviously, then companies might have needs that other customers wouldn't. And at that point, if they're big enough, we kind of have like consultants that work for that company. Or sometimes they even hire people to only work on writing recipes. Yep.
Just I guess an idea which I thought might be a bit cool. Because like it kind of loops back into the amount of effort it takes to create a recipe. Maybe in the future, if it becomes a bit more larger, the Modern and OpenRewrite, it would be cool if you could like parse change logs.
Yeah.
And just generate the recipe for you.
Yeah, absolutely. We're so not working on that right now. I don't know what you're talking about. Yeah, absolutely.
You'll be the architect.
I mean, that assumes that like the change logs are comprehensive of everything that they actually change. But I mean, it would at least get you like 80-90% of the way, right? Yeah.
So the change logs are interesting. There's a lot of information in it that make it a little bit hard. But we'll sometimes look at like, so Spring, if you work with it, they have basically this like toy repo called Spring Pet Clinic. And so that one, gets updated as they make new versions of Spring. So the idea of using maybe the diff on that then that would be good enough to get us to 90% of what are the changes to expect from the new migration of Spring. So using kind of like a before and after, that's a little bit more useful than the changelog. But again, there's a lot of human intervention still that's needed, just because at the end of the day, you kind of want to have that, the changes you want to make sure are good, and you want to have those guardrails. And so we rather have the bottleneck be the human at first, and then say, yes, I agree, all these recipes work. And then then having someone having to do the change by hand or some way. Sorry, I interrupted you.
It's just more so it's streamlined the process that, like, it would still require human verification, but like at least it wouldn't be like human has to write it from scratch.
Mm-hmm. Yeah, absolutely. Yeah, a little clippy like
test suites to speed along that verification.
Absolutely. Yeah, like a little clippy that's like, hey, you should use this recipe with these options. Absolutely. I think that could be fun. Yeah, you had a question or? Okay, perfect. Let me move on. We'll get to the AI stuff soon too. All right, we kind of talked about whose responsibility is to write recipes, so we'll move on. All right, so how do we see AI in general being used for refactoring at scale? So, there you go. So, you kind of have this, like, we're kind of a little bit anti-hype about it, even though I come from the AI world. That's what I did my graduate school in. There's something about making sure we're using the product in its right potential, in the right way. And, this is a slide that Mike going down. So obviously when, yeah, please do. Yeah, Tim will be very happy. I don't know. He added the blockchain for cat food. I think this is just the typical thing about like how it goes from kind of like the expectations not being met and then the plateau after. It's not, not just what we do with AI. But so even before I joined, basically they were trying to see, well, can I use AI with this? You have this, this framework, a recipe that can bring you in different places of code, kind of hold the AI's hand into the right spot of the code, and then they could tell the AI, oh, well, why don't you change this little part there? And it's nice. It's little guardrails. The AI doesn't have to see all the code. It can only see little snippets at a time. So that's what they did actually before I joined. And so one of the things they did was to put the default case last. So when you have a switch statement, basically, it is common for company culture or in general just guidelines to have the default case be the last one. So you can see in the first one in the top left that works because it's the last one, and you have case 1 and case 2 as the one on the second one to the right or top right corner. Doesn't work. The default is before case. Then on the bottom left, that works because there's no default. So there's nothing to put last. And the last one is also a violation. So we have a recipe for that that's deterministic, that does the change and it works. And it also doesn't change the fall through, which is an important logic to keep in your mind as you make those changes. So we saw the visitor design pattern, right? This is again the same thing, except here it overrides visit switch, which is for switch statement. So the idea is that as you see, when you see a switch statement, you say, all right, well, write the switch statement with the default case last. So this is what we're saying to the AI with basically this prompt. It works. Kinda. Oh no, it didn't work. That's not my roommate. It's a meme.
I've seen that one.
That is also Tim's slide. I just really liked it. So, you had to be more precise basically in your instructions. It would change the order and sometimes it wouldn't do anything. But really what was more dangerous is when it changed the logic, which it did happen a handful of times. So we had to be more precise. And then still there were still, some of the switch cases that were, okay, worst case scenario, they didn't change anything. You're still where you were. But sometimes the worst case scenario, did occur where there was change in the logic, that's just, not something you want to send, for scale. Okay, so we're down, to the valley, and this is where I come in. That's the graveyard. I like that. That's the graveyard. So we're at the graveyard, and here I come in, basically, and I'm like, all right, well, let's see how we can actually do this AI at scale. So one of the first things that I was tasked with doing was finding a better way to search for recipes. So we have a lot of recipes in our catalog, but it can get a little bit daunting to search for them. We had actually a potential customer I forget, that wrote to us and was like, hey, can you guys write a recipe to find method invocations or something like that? And we're like, we had that recipe. That's like one of the first ones we wrote. And turns out when they had searched, at that point we only had keyword matching. They couldn't find it because it was called find method usages. So that's when it was like, all right, well, we need to find a way to search better. So I don't know if searching is something that's useful in whatever work you do or in your product, but definitely for us, it was something that we're like, all right, we need something quick. We need something that scales and something that we run ourselves, basically. So, oops, I went too fast. So who here is familiar with embeddings? How about if I say vector representation? Okay, perfect. So basically embeddings are vector representations. Surprise, surprise. They're basically, you can see it in point in space. And the idea is that when two things, if you go and get the representation, two entities, if those two entities are similar in concepts, they will be near each other in that space. So this is where you have it here, where you have, one entity and the other entity, and then if they're close, they're going to be literally close if you go get their distance. And
check our distance that you're trying to use?
No.
What sort of distance?
You can use cosine similarity, or you can use just a vector distance from point to point. So then it depends if you normalize your vector or not, basically, from there. So here, what's important, just to kind of go through this quickly, is that you have this, you have this catalog of entities. In our case, it is recipes, but your entities could be, a catalog of shoes and clothes if you're an e-commerce site or something like that. So you can get basically using either the description or the name or the image. In our case, we use the name of the recipe and the description of the recipe to go and get that embedding, to get that vector representation. When the user then is looking for something, you can transform their query into a vector as well, and then you can check the distance between the two. So that's basically the concept behind searching. And just for sake of time, I'm going to go faster, but if ever you are looking into doing this, please make sure you see if you can't do also a second step, which is called re-ranking, which is a slower step, but at this point, you'll have a lot less things to match, right? So, and another point I'll say, just in case you guys are working on this, when you're looking to have these models, in our case, we wanted something that was open source because we couldn't call, a third party, an API or something. We had to run it in every single instance for our customers, because a lot of our customers have private instances of our platform. All right. So another thing we did was to go find recommendations for recipes. So at night, when no one is running recipes, you kind of have these like private instances, as I said, that are basically idle, doing nothing, just chilling somewhere. And so the idea is, okay, well, can I run maybe a model, an AI that can go and look at your code and see if there might be recipes you could apply that you didn't even realize we had, or that your code would benefit from. Sorry. So the idea is that you send basically some method declarations. You go and get that, again, with the visitor design pattern. You go and get method declarations. You take that little snippet of code. You send that to the AI, and you say, okay, you are a software engineer. Can you improve this code? You can also tell it it's senior if you want to give it a little ego boost. It tends to do better. So from there, we'll take this method declaration, send it to the LLM, and it'll give you a little recommendation of things that might be useful for you to do. But of course, this is completely false. This is a complete hallucination. That is not true. So what can we do to make sure that these recommendations are not surfaced to customers after? Well, you can run the recipe and basically, and you can use the search that we had that I just explained to find a recipe that might be related to what it's saying. So worst case scenario here, it says, okay, well, let me find you the recipe to upgrade to Java 8. It'll run it. If your code's past Java 8, nothing will change, and then you'll be good. So here I said that we take every method declaration. Well, actually, that is unfeasible. If we take here 1,200 repositories, the number of method declarations is 403K, so it's just not doable. You can imagine if it takes about 3 seconds to get one recommendation, you're up to 335 hours, and this is more than a night, which was the goal of the thing, is for it to run overnight. So back to embeddings. One of the things we can do with embeddings is to have clusters. So as I said, you have these vector representations, but they're just a dot in space, in multi-dimensional space. So once you have that kind of like scattered around, here I'm putting it in a 2D plane, but it's the same thing if it was more dimensions than that, you can basically kind of find these methods that look like each other. So if you have, method declarations that are test cases, so that's going to be one, cluster of methods that do kind of like a similar thing. Or you might have something that's more for logging, or something that's more for toString, stuff like that. The idea is that you want to basically make use of these embeddings to go do some sampling, but some sampling that's kind of smart. Because you don't want to do random sampling, because if you have, for some reason, a lot of toString methods. I didn't write this code, right? I'm saying this is an imaginary code that just for some reason has a lot of methods toString. Well, you wouldn't want to only get, recommendations for the toString methods. You'd like to diversify and have different, methods that do different things, that use different packages, because we talk a lot about migrations. You want to basically have a very diverse set of methods. So using the clustering, then you can find those centers of these clusters from there and be able to say, okay, well, say I want to only sample for method declarations and get recommendations for each, and then get the recipes and run the recipes. Then you have now those 4 circles, and you can just take the center method that's the closest to the center, and from there run the recommendation, get the recommendation, search for a recipe that does the change, run the recipe, see if it makes any change. If it makes any change, recommend that recipe. So that's basically the flow out of this. So it's just another way of using AI that's at scale, makes sense. Instead of having the AI that makes change here, you're using the AI to do a smart, diverse sampling, basically. Any questions about this? So here you would have, like I said, the method in there. So this is the whole pipeline. To go over it one more time. You have your code that's parsed into LSTs. You have this recipe that goes and embeds every single one of your method declarations. From there, you get centers for your recommender. So it only sends a couple method declarations. It sends that to basically some generative model. And from there, you get the recommendations, you parse them, you send them to your search, which I just described earlier. You get your recommended recipes, and then you can run them and see if they make a change. So this whole idea of having this pipeline, and the reason why we do it like this is because here, like I said, we're dealing with, a scale that is of 1,000 repos or more. I was talking earlier of maybe someone that only had 100 repos, but we need this stuff to also work for clients who have more than 1,000 repos.
Sorry, you just mentioned the recommendation, I understand you're trying to offer a service to a customer that's like, hey, you should do this to your code. Is it more you should upgrade this framework or this library, or is it more you should follow these best practices?
It's a little bit of both. So it'll surface some that are about migration. So like, oh, I see you're not using random secure kind of thing. You're using only random. Or it can be something also about vulnerabilities. You know, if I guess the random secure is one of them, but it can be something else about more how the data is being, ingested. But if ever we don't have a recipe for that, then we just aren't able to recommend it. We never surface the actual recommendation because, like you saw, sometimes it's just not a good recommendations. There's too many hallucinations. However, it will pick up on some patterns like, oh, it was using Java 8. So that's good enough for us to go see, okay, well, maybe it would want to migrate to Java something else.
And that's useful because like there's so many repos at this organization that the person that's in charge of the repo doesn't realize their Java version is out of date and can just say, oh, I just want to update my Java because the scale is so large.
Yeah, exactly. So it can be that. I can show you guys the Dev Center, which is kind of like the entrance point for especially more managers as they walk through migration strategies. But that would be basically where the recommendations would be surfaced here, where it wouldn't be the Java ones because those are typically the first ones that we put up there, right? Because it's kind of like the big thing that people want to do. And like Nicola was saying, like they'll spend, a year or two on it and only get 10% of their repos upgraded. But maybe more smaller things like, oh, this little dependency that we kind of forgot about. And because we have a lot of open source, a big open source community, people would add, recipes that might not make it to the newsletter that basically they wouldn't find out about. So it's more for those other smaller packages than it is for like Spring Boot and Java, which people seem to be enough aware of. Yep.
I'm puzzled as to why you're running this whole CPU. Those recipes, you have a vector of recipes, you can port it through CUDA into some sort of OpenMP instantiation, and you can get much higher throughput. Why? It's not worth it? It doesn't pay?
It's very expensive, GPUs. They're very, very, very expensive.
I see. So at this point, there's no utility.
There's no bottleneck on speed right now.
Okay.
Maybe one day.
That's what I was
but
thinking.
Right now, the speed is good. It's really quick.
I see.
I can, we can run a recipe and you'll see how quick it is.
Plus, it's a bit about accessibility.
Yeah.
Because if you make it so that it requires a high performance GPU, well, then you're locking out a chunk of your potential user base, right?
Yeah, exactly.
Oh, I understand. Okay, it's a matter of usability. So you might have a high-end customer that would be able to use that kind of solution, but for the time being, it's not a.
There's it's a sentence I say a lot, and it goes back to even just using AI. We were looking at this like generative AI making the changes in the code as opposed to a recipe. And it's kind of like buttering your toast with a chainsaw. Mm-hmm. And sometimes GPU versus CPU can kind of be that, where it's like, I love GPUs.
I love that overkill.
Thank you. That's a Juju original. I actually came up with that one.
I
know, right? I need to. But it's just GPUs are fun, and like I obviously use them a lot. But we're kind of for the AI part of things, at least, we're a little bit more of the school of thought of like you use GPUs to train the models and then use CPU to deploy them. Because until we're proven otherwise, CPUs work well enough. You have to be creative, but that's what boundaries are for sometimes. It kind of forces you to really, reach the limit of that and then push it further than you thought it could.
So we're speaking about tens of recipes, never thousands of recipes, for example.
That are running at once?
Yes.
Well, no, because Spring Boot is like over 2,000 recipes.
Okay.
So yeah.
And still it runs well on the CPU.
Yeah. Well, more than one CPU, but yeah.
Yeah.
But it's still much, much cheaper than GPUs, yeah.
Understood.
I mean, like the GPUs that they use for AI and stuff like that, like not only are they in like super clusters, they're like $3,000, if not more, per GPU.
Yeah.
$3,000 is a find that GPU.
Yeah. That's a 3090 is what, 4K
Yeah,
now?
but they've also got like dedicated GPUs
Yeah.
for AI processing. And those ones are expensive.
And then you can use TPUs. Yeah.
I know it was a lot. I was saying like 3,000, but yeah, no, it makes sense.
Like A100s are, I think, yeah, they're like they're at least more than 10K, and then I don't remember the exact price, but they're more than I was like, I can't buy this. Yeah. And then you still need CPUs. That's the thing, is like you still need the CPU to run the GPU.
These are this is 2,000 virtual threads.
Oh, then I can call up my the SaaS manager, but that is way outside my knowledge. No, it's all good. I like the questions. I can ask him on Slack after, but I definitely
on Discord.
Yeah, on Discord, sure. All right. So another thing that we have, as you'll see, we're kind of not. We don't want to make the change using the AI. We kind of want to use the AI to guide us in how to make the change. So one of the projects we did, actually this was with the intern from Mila, where we wanted to find a way to search for method invocations without using only method patterns, right? Without knowing exactly what the method name was. This problem kind of started when basically we went to go see a potential client, and they wanted to change their, what is it called? Access management provider identify. Yeah, the thing in the HTTP, HTTP request, basically. All that to say, they need to change an argument inside all their HTTP requests. So they said ACM access, whatever. I'll go find it after. Maybe. I know it's bugging me too now. I wish it's like I said, that's, no.
Can't generate AI give you the solution?
Yeah, maybe. Then I would have to start it up. So anyways, but all that to say, they need to find basically they need to change an argument inside HTTP request calls inside their Java call. That's all that we need to know. What happened was, okay, well, let's write a recipe for that together. Let me show you how we write a recipe. What a great learning opportunity. So they sit down, they write the recipe, and from there, basically, they run it, or rather, I forgot the spot. They said, okay, well, what libraries do you use? And he was like, oh, I use OKHTTP, and we use also like a web client from Spring, something like that. Okay, great, perfect. They write the recipe, they run it. And the recipe does some changes, perfect, except then the potential client goes, oh, shoot, I was expecting a change in this repo, and there wasn't one. And they say, okay, well, let's go check it out. So they open up the repo, they go and find one, and they go, shoot, there was a third library we forgot about that does HTTP requests. So the idea is basically, you want to basically have this recipe, this search recipe here, where you can just say HTTP request, and no matter the library, it will find you those method invocations. Now, this is not the recipe that'll make the change, but it'll show you basically all the different packages that you use, so that then you can write the recipe to make the changes. So it's kind of a first step that helps you make sure that your recipe does everything that you would expect it to do. So do I have any? Maybe I'll start by explaining it first. How are we on time? Still got a bit of time. So these, it's, again, we're talking about at scale, right? Especially for a problem like this, where it's discovery, you want to be able to run it on more than just one repo at a time. You want to run it on many. And so the idea here is, if we were to do a search, it would end up being like 10 hours if we were to just, kind of naively just check every single method invocation, still using AI. Then you would have about 10 hours for 1,200 repos. And that's just not feasible. You can't, it can be. I know that there's some COBOL providers that, it takes about 2 days for a search result, and that's only using method patterns, but that's COBOL. So we wanted something that we could do that was going to be a little bit faster. And so this is where you can see type attribution really shining. and really bringing basically AI to the next level, where basically what we do is we go and get, again, surprise, surprise, an embedding for every method invocation, or sorry, every method signature that is in use in the code. So once we have these embeddings for all of these method signatures, you can then get a top K of what type of methods would be more likely to do the action from the query. So if you were to write, okay, HTTP request, if you have a method like toString or log or cache, then you probably know that that method is not doing the thing you're looking for. But if you have one that says send request, or new HTTP request or something like that, then it's most probably going to be doing that. What's cool about this too, because we have the type attribution, you also have the type inside the arguments and what actually it returns. So if you have a method that is just called new, but it returns an HTTP request object, then that's the information that basically, because we have these LSTs that have these type attribution, we're able to actually have the full information in the method signature. All that to say that basically we're then able to have the top K and go get only then the method invocations that are part of those method signatures. Yeah. Yeah. Yeah, that's where I'm saying, it's out and it's working, but it's still in baby phase. I think it does work on type hints in some ways, but that's definitely more something to keep an eye out in the next month. Yeah. Are you mostly a Python developer? Nice. Me too. So type hints, I think, are definitely going to be interesting. Like JavaScript is similar to where how do we make sure we're able to get the same amount of information? Do we just accept that we don't have it? That's, again, not my area, but I think it's a very good question that I was actually asking myself the other day. Okay, so to go back to this whole pipeline again, and as you see, I love doing graphs of the different little steps that we do, because I think we get pretty clever in basically chaining, kind of like in subdividing the tasks to the appropriate tool. So we have this LST, which is your repo that gets ingested, that gets parsed. We have a recipe that first and gets the method signatures. We get a top K. Using the user query, then we get also the embedding for that. And from that, we get the top K, and then we're back over here. And finally, we can actually do the search. And as you can see, there's 3 robot heads, because actually, this is the part that gets a little bit more nerdy on the AI side. We wanted this to be really, really swift and quick, and like I said, we're CPU, so there's definitely a bottleneck there. So what we did is we ended up chaining 3 models that grow in size, basically. So you start with a smaller model, an embedding model that's like microscopic, super tiny. And then you have a medium-sized embedding model that's a little bit bigger, a little bit smarter, because as models get bigger, they have a better chance of understanding the data that they're trained on and doing better on test sets. And finally, we have a generative model, because we found that was the best model at the end. So we did a bunch of testing to find which combinations of these models to use, and we can talk about this later if this is something that interests you. But basically, we had to find thresholds for each of the models except the last one, where basically if the first model was like, I am super sure that this query and this method invocation match, then we didn't need to go see the more expensive and slower models. And when I say expensive, I mean expensive in time and compute. If ever it was super sure that it's not, they don't match, same thing, no need to continue down the pipeline. However, if it wasn't sure, then you wanted to go to the second model, and then the same thing would happen at the second model. Are you sure? Are you not sure? Are you unsure? And based on that, go to the final third model, which is generative, which is always a much bigger model than embeddings, and therefore much slower, but more powerful and more able to generalize. So that is basically the idea. All right, so we can go see now how this actually looks like here. So I ran this recipe on, I think this is 12 repos here, and my query was cache. So I wanted to see, okay, we have like these 12 repos. This is our organization, like a set of repos that we called default. So it's like the one we kind of either debug with or do demos on, because it's small enough that it's very quick, and it's very diverse. There's a lot of different technologies in it. So this is what I did here. So if we go see cache, we see that there's a few different examples so we can go see the Spring Pet Clinic, the one I had talked about. All right, so we can see this. And so this is now the platform. So our customers that have their own platform are able to access the same things, but with their own repos. And then here you could even, click on it and go see, all right, well, this is here. All right, so they kind of have the Spring framework. You can kind of go through all the different examples and see what they have here. All right, this is processed cache stats. And as you saw, I just put cache to make sure I would grab the most examples. I didn't actually care if it started the cache or if it deleted it or if it did whatever to it. Same thing here. But this, this idea of going to click back and forth is kind of annoying. Yes, it's a little bit faster than if you had to go search yourself for it. But we also have the visualization, which I now close, but here, which is a data table that gives you everything. So as you can see, it's a little small. Well, maybe not too small. So we have one from Google, we have one from Netflix itself, one from Ribbon, some from Springwork, Apache Maven has some. So we can see all the different libraries that they use for cache. So say there was a security, check that was happening for my company, and for some reason they decide that caches can only be 1,000, entries long for some reason. Then this would be a great first point to go basically find which libraries actually deal with cache so that I can then write the recipes to change the argument for each one of those. So that's basically the idea here. Let's see where we are around the end. All right, how are we on time? I kind of want to talk about this because this is what I'm working on right now, or more recently. Another thing that I wanted to do with AI is that, I talk about parsing these and getting LSTs like it's magic. There's sometimes going to be dependencies that need to be added before we parse the project. There are some steps. So customers or any big entity that needs to get, or even ourselves for the repos I showed you on the public platform, they can give us a CSV of a bunch of repos, basically. So from there, we take each one of those repos, we download them, we parse them, and then sometimes they won't, or sometimes we build them into LSTs and they won't work for some reason. So one of the things I worked on a couple months ago was to basically, again, find these clusters of build errors so that whoever's in charge of making sure that we have this like mass ingest process, which is what we call when we build a bunch of LSTs for a bunch of repos, they can go and debug what needs to be done faster. So this idea is that because this product is so powerful at scale, we want to make sure we give the tools to whoever is in charge of this mass ingest to basically move forward faster and debug the different reasons. We do a similar thing. This is what I'm working on right now for parsing. So I was talking about the JavaScript, the C#, the Python parsers. As we're walking through parsers, sometimes there's going to be parsing errors, right? There's going to be, we don't have a type of node for that. It won't be able to cast. Or sometimes for those with Python, how before we could, call print without putting parentheses. That, was actually one of the parse errors that I saw because that was from Python too. So you want to be able to do the same thing here. And this is now what I'm showing you in this one. This one is for the public, for our customers, but we have one internally as well for our language engineers, the ones who actually push the parsers to other languages, to be able to use that and iterate as they're working on the new parsers, basically. So that's the idea behind it. So again, my thesis, I don't know if it was clear, it's like use AI at scale. Yes, absolutely. But it's really good at a couple of things that you can trust it almost blindly. And then there's other things that it's pretty good at, but maybe shouldn't trust it blindly. We advocate for using OpenAI, ChatGPT, Copilot, Gemini, whatever you want to use to write recipes. It's a great coding buddy, but it's not the thing that should make the change at the end of the day just because of what happens if there's a 1% failure. You would see that a lot in your code and it can get pretty dangerous. So we are at the end, everyone. We are at the end, everyone. You didn't see that slide. I don't feel like talking anymore. So we wrote a book which kind of goes more into details about the different stuff that I talked about today. Sometimes we focus a little bit more also on the AI side of it. So you could get your free copy. It's only 30 pages long and I think it's a fun beach read. And finally, we have the code remix, which actually this was announced yesterday. So we will be having our first summit where basically this is OpenRewrite, Modern, a bunch of our clients, a lot of our contributors that come, and we are going to talk about this framework and what you can do with it. And I'm going to be presenting as well there. And it's Miami. It's at the Margaritaville Hollywood Hotel. So if that's not enticing, I don't know what is. I saw the pictures yesterday, and there is a little fake surf, when they push the water on this module and then you can surf on it. They have that. So that's fun. So let's learn about refactoring together and learn how badly we can surf on fake waves. So if you do want to attend, there's right now a $300 discount, and I believe there's an additional $300 discount. If you message me, I'll give you the code for it. I forget exactly what it is. I would tell you otherwise, but it's Modern something. So we're at the end. If you have any questions, I will stay for a little bit. And thank you all for your questions throughout. I'm really happy we were able to make this more a conversation. They're always a little bit more fun than just to spew what I know. So yeah, any knowledge, any cool stuff you guys are working on?
You're doing more interesting.
Appreciate it. Thank you.
I'm just curious, you said I haven't looked into your background, but you said you did like a master's thesis or something like that. Did you get connected to Modern through that?
Yeah.
Or were you just job searching, like a regular job searcher?
Yeah, no, it was really likely a meetup through basically, I was in charge of the reading group at Mila for machine learning for code, basically. So it's any application of machine learning, whether it's graph neural nets or just your traditional LLM transformer. So the idea is that we do, a meetup every 2 weeks or so. And we like to sometimes have, especially other PhD students or professors, but sometimes we like to have also a little bit of industry input. So I had a colleague who had actually used OpenRewrite in one of his research projects and had recommended OpenRewrite co-founder Jonathan to come and discuss it with us and what he did. It's interesting because it's, I say, OpenRewrite's not AI, but when you look at the definition of AI until 95, 2000s, OpenRewrite really fits in that. It's just using a set of a logic to emulate intelligence. And that's basically what it is. But it's in the same way that, if you look at one of the kind of toy examples of an AI algorithm, which is getting out of a maze, if you just put your right hand on the maze, you will most likely be able to get out in a suboptimal way. So there's no learning from the past, right? That's only when you get into machine learning. But when you're just looking at AI, it's just an algorithm that is kind of smart. That's really it. So that's why it was really interesting to have him come and discuss this, because it's another way to look at code, because we were, us at Mila, we're so stuck on the deep learning way of it that it was really nice to get that contrast. And then from there, at the end of the talk, we just started talking about how to bring more modern AI, no pun intended, to Modern. And from there, a job was created for me, which was a really nice experience.
You were the only applicant?
I was the only applicant, yeah. Yeah, that is definitely, I was very lucky. Yeah.
You mentioned Cobol.
Sorry?
You mentioned Cobol?
Yes.
Could it be used to transform Cobol to Java?
Yeah, that's a little bit the next step. So one of the next things we're working on right now is to kind of treat the LSTs as knowledge graphs. And one way that would be interesting to use that would be to be able to, kind of not necessarily, do the whole translation from one to the other, but at least be able to give you kind of the skeleton, Halloween, the skeleton of your code to be like, okay, well, you have this kind of business unit is in this, and that's how it's organized, and it connects to this. So to have basically the ability to talk to your COBOL code to extract that structure, and then that can be used to kind of get to the Java stuff. So it's not necessarily going to be a translation like click, it's done, but something that kind of gets you even like maybe that first 30% can be daunting, and it also lets you know it's going to be a good impact analysis to know, okay, well, how many hours, when really it's more like how many days and employees will I need to do this transformation based on this this like first understanding of the task at hand. So yeah, great question.
I have one example. Wouldn't it be easier to compile than to reverse compile to Java? Would that be an easier step?
Then what, sorry?
Then trying to rewrite the COBOL, wouldn't it be more efficient to compile it into an executable than to reverse compile it to Java?
I don't think we're rewriting COBOL, but the strategy you're talking about, that is how they were working on doing sometimes translations from one language to another in more the deep learning research. This I'm talking like academia. It didn't scale very well. It worked a little bit, but it didn't go very far.
The thing that is like if you have any libraries or dependencies for translate like compilation or translation from one language to another, like you need to make sure that the libraries used in one are available in the other, and that they have like same callbacks. And there's a lot of things that like can go wrong with that if like you're not.
You don't translate. I understand.
Yeah.
Yeah.
About the cache example.
Yeah.
And the query. Could it handle also the AOP when you plug some code on your codebase at runtime?
I don't know what AOP is.
But then you plug some cache to aspects.
I don't know enough about, what did you say, AOP?
AOP, yeah.
IOP.
So, aspects of your programming.
Oh,
You
okay.
just plug some aspects on your codebase, but from scratch, there is no cache available. But on the runtime, then you plug something, and you could have some cache on some methods.
Do you have access to the code for that? Like, is it somewhere? I don't know how it would run. So if you have access to the code that you inject at runtime, then yes, it will find it in what gets like in that repo.
Mm-hmm. So by name or attributes or whatever.
Yeah.
And then you can plug some code around the base.
Yeah. My intuition would be yes, I think that would be found. But that would be a good question for the we have a OpenRewrite Slack, where there you'll actually have the real Java experts, the people that can kind of answer those questions a bit better than me. Now that I've been there for a while, I can answer kind of like the first few rounds of questions, but when we get to the fourth, fifth one, it starts to be outside of my expertise. But my intuition is yes, but I could be wrong. All right. Well, thank you, everyone.
Thank you.